x cosine 3x dx. So this should be another form that's pretty familiar to you. Not only should it be pretty obvious that we're going to have to use integration by parts because we have two functions here which we could definitely not use u substitution on that are multiplied times each other. But when we have the specific integration by parts problems that are exponentials and trig functions multiplied together, we're always going to get the cyclic integration by parts that we're going to have to rearrange and move to the other side, and we get it in terms of itself. So in this case, it's going to be a little bit more complicated than the example you probably went through in class, just because we have a 3 there, so our numbers are going to be a little different, but it works out the same way. So the first thing we want to do is the first step of integration by parts. So it doesn't matter which one you set, u and dv. I just always prefer to have the exponentials as the dv. So we have u equals cosine 3x, dv equals e to the x dx. Therefore, our du, the derivative of this would be negative 3 sine 3x dx. And our v is just then e to the x. So now to do your integration by parts formula, we have uv e to the x cosine 3x minus the integral of v du. Now v du is negative, so we can actually just put a plus here. And we have a 3, which could be on the outside of the integral. So we really just have e to the x sine 3x. And as you can see, this one we're going to do in the same way. But what's going to happen is when we do the integration by parts of this one, we're going to end up with cosine again. But that's what this is all equal to. So we'll be able to move it over and everything will work out nicely. So let's do integration by parts one more time, now of this underlined part. So again, let's set the u to be sine of 3x. Our dv is going to be e to the x dx. When we do our derivative, this is just going to be 3 cosine 3x dx. And again, our v is just e to the x. So what do we have now? Well, this is still there from before. This 3 is still there because everything that we're going to write now for the integration by parts was what this integral was. So it's 3 times everything. So we have u times v, e to the x sine 3x, minus the integral v du. Again, we have a 3 here, so we can put that in front. And v du is just going to be e to the x cosine 3x dx, which is what this whole thing is equal to in the first place. So what we need to do now is just distribute everything, and you'll see how it'll work out so that we're done, really, at this point. So this is equal to everything we have over here. So we have e to the x cosine 3x plus 3 e to the x sine 3x, because we have to distribute this 3 to everything. And then we're going to have minus 9 of integral e to the x cosine 3x, which is what is over here. I'm just going to write the integral there for now because I'm running out of space. So therefore, if I have an integral of e to the x cosine 3x here, and I have minus 9 times that same integral over here, I can just add that over and combine them together. And what we would get then is just 10, because we have 1 plus we're adding 9 over. E to the x cosine 3x dx is equal to just what was left here. And what I could do there is factor out an e to the x, because they both have that. And what I have then is cosine 3x plus 3 sine 3x. So if I want to know what the value of this integral is, all I have to do is divide by 10, and you have your answer. So therefore, the integral of e to the x cosine 3x, which is what we were looking for, is equal to what we just had over here, e to the x times cosine 3x plus 3 sine 3x, all over 10 plus c, because again we have an indefinite integral. So by using integration by parts twice, we're able to return to our original integral, and as soon as you've got your original integral, you can just move it over and everything works out perfectly. So this is our answer here. So you should be expecting this to happen when you have functions, when you're doing the integral of functions that are exponentials and trig functions in the same integral.